Um, I thought I would make a video to explain the question 5, chapter 6 review questions. This is the question 5. Let me find the question first. All right, in the review question, question 5 is, all right, question 5 is, on October 1978, purchased a laddered portfolio of 8 2000 par value bonds. Each bond in the package have an annual coupon and a coupon rate of 7.3. So if you take the 7.3% with the 2000, you get 146. So there's an annual coupon of 146. And the last payment should be $2,000 at expiration. The redemption dates were October 30 of each year, starting 1980 to 1987. The package was priced to give Mr. Cohen 8% annual yield rate. So we were supposed to find the price of the portfolio. That means we need to find present value of all these cash flows. So it looks like the solution that you guys had was a little bit off, and I'm trying to think of an easy way to answer the question. So hopefully we can use the formula that we already had and try to get the present value of the cash flow calculated. That will be the price of the package. So I started looking at all these bonds. So for example, the first one expired at 1980 and it has an annual coupon. So expiration is 2000 plus 146. And then the second one mature at 1981. So you have 146 the 2 years before and then 2,146 later. And we can analyze that way. I draw the timeline for all of them just to have a clear idea of what's going on. And then the last one, number 8, has 146 coupon until the year of 1987. Okay, so it seems to be an uneven payment. So I look at a way to separate them into an easier to calculation format. If you, this person hold all eight bonds. So the cash flow for all 8 of them can be combined. So if you look at the coupon for 1979 is 146 for each bond. So the total is 146 times 8. All right, and then for 1980, there's a 2000 expired bonds. So then the coupon is 146 times 8 as well. And then the year after is 2000 expiration maturity value. And then the 146 coupon is one less because the first one already expired. So I started drawing a different timeline. I have the maturity value, maturity payment, they're all 2000 because the face value is 2000. So you can think of it kind of like a annuity of 2000 each year starting 1980. So I feel like this calculation can be done using the 2000 times A8 0.08, but that will be the present value at 1979. We have to discount that to get the 1978. That's why there's this extra discounting factor there. So we multiply 1.08 to the -1 power just to discount it until the correct time point. So that is the cash flow of 2000, the value of that cash flow at 1978. Now we can look at the second cash flow. I kind of combine them into one cash flow, one timeline, and then there's a common factor 146. Factor that out, so you have AA765431, and then the time goes up, the value goes down. So I did that discounting each value to get the total present value of that cash flow. And this is what I have. And then when you add it all together, that's the total present value. I hope that kind of explained this one in a slightly easier way. This is the easiest way for me to think of this one. It's pretty complex if we have to do it one by one, but it's also possible to calculate the present value of each one and add it together. So there's multiple way to do the computation. If you wish to use a formula that was posted in chap like chapter 3, 3.8, 3.7, 3.9 for the non-level payment, there might be a better way, but this method does not involve too many formula for us to remember.